So welcome back to another Daily AI. After we have seen in the last video how the Plan and Execute Agentic AI can work, let's see how we can now implement this in the Python notebook. So let's jump into VS Code, where we first need to set up the project. So basically installing the packages, for example, LangGraph. Then we also need to set API keys, for example, for OpenAI and for Tavali. We define our tools. So we want to connect the LLM to the internet. Therefore, we are using Tavali. Next, we define our execution agent, which we want to use for executing tasks. So here we are using OpenAI. So let's try this out and calling this simple React agent, how it performs on our question, who is the winner of the US Open? Answers the question, so man single Novak Djokovic. But now let's try to put this into a Plan and Execute agentic workflow. So first we define the state, which is tracked in the LangGraph. And this will be a plan execution. So the plan execution requires our input, so the question the user has, the plan coming from the planner, the past steps which have been already undertaken by our execution agents, and then lastly we have the response which will be returned to the user. Next we define the planner. For the planner we first need to define how a plan looks like. A plan is basically a list of strings, so we refer to as steps, which are different steps to follow and then should be also sorted in order. And this plan we then forward for our planning agent, and then lastly force the planner to only output our base model, so our plan, starting with identifying the current year to determine the most recent Australia Open winner, then research the winner of the Australia Open for the current year, and lastly find the hometown of the identified winner from the Australia Open. We would then execute this plan, but also we need to have a replanner. For this we first need to define how a response looks like. A response is very simple, just a string. We then tell the replanner what actions it can perform. So either responding with an answer or creating a new plan, so replanning the original plan. So we create the replanner, so from a chat prompt template, and then we create our actual replanner agent by chaining our replanner prompt with an LLM. And then lastly, we also bind our action model to the planner so it can only output the structured output. So basically either answering with a response or with a new updated replanned plan. So after creating our planner, our replanner, and our agent executor, we can now start with creating the actual LangGraph by first defining an execution step. So the execution step gets the current plan from the state, from the LangGraph state, then gets the first task as the one being currently executed, and then asks the agent executor to perform this task. And lastly, we update the state with regards to the past steps. So we have already undertaken the current task and add then the task as well as the result from our execution agent to the past steps. And we also define our planning step. Here the planner is being invoked with our user request and the plan is being updated in our state. And whenever an executor has executed a single task, we also want to replan our original plan. Here we are using the replanner agent we already created, invoke it with the current state. So whenever the replanner thinks the plan has been fully executed, we return with a final response of our action. Or if the replanner has actually been replanning or continuing our plan, we return the steps. And lastly, we also need to define a step to tell whether the agent should either stop. So whenever there's a response in our state, we tell, okay, the agent execution has been ended. Otherwise, we forward again to our agents. After creating those individual nodes, let's now add those also to our LangGraph. So we create a state graph for LangGraph. We then add first of all our planner, our execution agent, and then lastly our replanner. But we also need to tell how the workflow flows, so how to jump from one node to the other. We do this by adding also edges. So we always start with the planner, and after the planner we always execute the first task of the plan. And after every execution we replan the original plan or return with a response. We also have a conditional edge, so this uses our should-end function to determine whether the last replanner agent has been replanning the plan or actually returned the final answer. And after compiling the workflow, we can now try our plan and execution workflow. So we again ask what is the hometown of the men's 2024 Australia Open winner. And after 20 seconds, you have the final response. So the hometown of the Yannick Sinner, the men's 2024 Australian Open winner, is Sexton and Dolomites. And you can also see the reasoning behind the entire workflow. So it starts by the planner defining our plan. You can also see the in-between steps. So whenever the replanner was called, seeing those past steps, which has been already done. So here we have been calling Tavali to tell who has been the winner of the men's 2024 Australia Open. And you can then afterwards also see that the replanner has been actually more specific in the updated plan. So research the winner's personal background to find their hometown, to research Yannick Sinner's personal background to find his hometown. And here the replanner already decides to return our final response, as all the information has been already gathered. So you can see, even though originally the plan was to perform 4 separate steps, we actually only performed 2 steps, one being identifying the winner and the other one researching on the personal background and then already returning.